Hello everyone, welcome to Math Hands-On class with Python, and today we are going to have a lecture session on operations research on the topic called the assignment problem. So we have a set of objectives. By the end, each one of you should be able to identify and explain the assignment problem, represent an assignment problem in the LP model, describe Hungarian method to find proper assignments, and solve balanced or unbalanced minimization and maximization assignment problem. So assignment problem basically is a special case of a transportation problem in which the objective is to assign a number of resources or person or a machine to the equal number of activities. The activities can be jobs or tasks at a minimum or maximum profits, depends on nature of the assignment problem. Unlike transportation problems, all sources and demands in assignment problems are equal to 1. So the assignment problem arises in a variety of situations. So a typical assignment problems basically arise when you have a problem of assigning jobs to machines, assigning sales personnel to sales territories, assigning contracts to bidders, assigning agents to tasks, and assigning taxes to customers, or other problems of this nature. Okay, this is a network representation of an assignment problem. So the assignment problems, basically, as I introduced, normally it works for n jobs to n persons or n tasks to n machine. So number of jobs and number of machines should be equal. So here we have sources as resources. These resources, as I described earlier, resources can be machines, persons, or anything which can perform a certain activity or task. And activity, there are different set of activities. So we assign one resource to one activities, and the C and N, this is C11, these are the costs associated by assigning a certain resource to a certain activity. So this cost, or whatever it is, will determine which resource will be assigned a certain activity. Okay, now let's see how you can formulate the assignment problem when you have a situation like that. So if the cost of doing jth activity or a job by ith resource or person is identified, okay, then the cost matrix associated by doing jth activities by ith resources can be presented in a tabular form as presented here. This table normally is a collection of different persons performing different tasks, and here inside you collect the cost. So the cost of assigning person 1 to job 1, you list the cost, or you write here the cost associated by that assignment. If person 2 doing task 3, then you put the respective cost there. So this is how you can summarize the problem from word problem into a tabular form, and you come up with the assignment problem of this nature. So remember, I insist, the assignment problems, basically you have nth task and nth resources, okay? So one person should perform one activities, or one machine, one task. So after formulating the assignment problems in a tabular form like this one, now we are in a position now to formulate an assignment problem from this tabulation form into a mathematical model, which is LP model. Now, a mathematical model of an assignment problem basically is represented as follows: that you have the minimization the minimization function, that is the summations of the product between the cost and the associated assignments, as I varies from 1 up to n and j varies from 1 up to n, where this xij can take one of the two values. The xij can be 1 if the ith person is assigned jth work, and the xij's can be 0 if the ith person is not assigned the jth work. So this cost function is written with the restriction that the summation of xij as I vary from 1 up to n is equal to 1 if the ith person will do only one work, and the summation of xij as j varies from 1 up to n when the jth work will be done only by one person. Now, from this general mathematical model formulation of the assignment problem, we can pick a particular example to demonstrate how we can formulate a mathematical model for an assignment problem. So now let's consider an example of this table where we have a number of resources. Let's call these machines, and a number of jobs or tasks. So we have 4 jobs and 4 machines, and these machines have their cost associated by assigning to a particular task. Now remember, the cost function is the product of an assignment and the cost. So here we have the cost, and assigning m1 to j1, let's call it x11, assigning m1 to j2, let's call it x12, and assigning m4 to j4 as x44. So the cost function will be the sum of the product between 10 times x11, 9 times x12, adding row wise until you reach times 6, plus 6 times the x44. So doing that, we are going to have this kind of model from this table. So you can see the minimization function here is the products of this, or the sum of the product between this cost and the assignment at this particular position. So it's the sum of these products between the cost and the assignment up to this last cell, such that the x11 plus x12 plus x13 plus x14, this basically represent the restriction. This set of equations here represent the 2 restriction. So these are the restriction row wise, okay, and then you have 4 other restriction column wise, okay, these last 4, where the xij, this x11 up to x44, they are greater or equal to 0, okay, where I takes the value of 1 up to 4 and the j's take the value of 1 up to 4. Now let's see the types of assignment problem. So the assignment problems are classified into balanced assignment problems and unbalanced assignment problems. So if the number of rows is equal to the number of columns, then the problem is termed as a balanced assignment problem. Otherwise, an unbalanced assignment problem. How do we balance unbalanced assignment problem? Basically, like unbalanced transportation problems, unbalanced assignment problem is balanced by adding of a necessary number of dummy rows or column, such that the cost matrix is a square matrix. Remember, I insist again, in assignment problems, the number of tasks should be equal to the number of persons or machine or resources, okay, that they should perform that tasks. So if the number of tasks are less than the number of resources, then you need to add a dummy activity. And if the number of resources are less than the number of tasks, we add the dummy resource. Okay. So the values for the entries in the dummy row or column are assumed to be 0.